Hello, this is Yulin, and I will explain the homework 5, question 1. And we're given that x and y are independent with f and z equals to x plus y, and we need to find the fz of z, and we know that fj of z is the convolution of fx of z and fy of z. So the first question is we need to use the convolution method. We use the convolution method, we write the formula here, and because we know that x is only have value from 0 to 1, so we could rewrite the equation like this. And from y from fy of y, we know that only when z minus alpha greater than 1 and less than 2, there's there's value. So uh, we uh, we discuss this by parts. When when z less than 1, there's no value. 0 times 0, so there's 0. When z greater than 1 and less than 2, there's some interception, and there's value from 0 to z minus 1. And when z greater than 2 less than 3, there's a value between z minus 2 to 1. And when z greater than 3, greater and equal or equal to 3, the convolution is 0. There's so we rewrite this like when z greater than equal to 1 less than 2, fj of z is z minus 1. When z greater than or equal to 2 and less than 3, fj of z is 3 minus z, and otherwise fj of z equals to 0. The second problem is we need to do this convolution in geometric method. Uh, Geometry method. Geometry method. I draw the function on here, and it's fx of alpha, and we could say it's uniform distribution from 0 to 1, and fy of minus y is a function from this uniform distribution from minus 2 to minus 1, like here. But now we need to find fy of minus y plus z, and it could be viewed as move z step from here, and it's like this. When z less than 1, there's no intersection between two functions, which are the two functions on the same diagram. And when z greater than 1 and greater and equal to 1 less than 2, there's intersection, and the intersection is z minus 1, because this length is z, and we minus 1, and we got the intersection. When z greater than 2, greater than or equal to 2, less than 3, we see the intersection is there, and it's equals to 3 minus z. When z is greater than or equal to 3, there's no intersection. We could see there's no intersection. So finally, we could write the the fj of z. When z greater than and equal to 1, less than 2, fj of z equals to z minus 1. And when z greater than or equal to 2, less than 3, z equals to 3 minus z, and otherwise there's a 0. So this is the first question. The question 2 is we're given that fxy equals to a over y squared times x, and y greater than or equal to 1, x greater than 1 over y less than y. So we draw the we draw the region of f of x and y greater than or equal to 1. So the region is above the line y equals to 1, and x greater than 1 over y is the region is this region, and x less than y, so the intersection of these three regions is here. Now we need to find a that fx and y is a value joint density function. So that means if we integral the f of x and y from minus infinity to on the whole plane, it must be equals to 1. So but we know the limit or the bound of this integral. So we integral x from 1 over y to y, and then we integral y from 1 to infinity, so it must equal to 1. And we use some techniques about the integral, and finally we got that a equals to 1 over 2. And the third question is we need to find and draw the margin density function f of x and f of y. So from f of x, we integrate this function by two parts. The first part is x greater than 0, less than 1, and in this part the integral region is from x 1 over x to infinity, and we integrate this. Finally we got in this region fx of x equals to half, and when x greater than 1, and we know we integral y from x to infinity, and we got the result is 1 over 2 times x squared, and then we integral, we found fy of y, and it's from 0. The integral is from 0 to the integral is from 1 over y to y, and we integral x. So we got line y over y squared, and when y greater than and equal to 1 or equal to 1, and we draw the function is fy of y, and this one is fx of x. Finally, we need to verify this two density function. So we integral fy of y from minus infinity to infinity, and we know that is equals to 1. And the second is we integral x from fx of x from minus infinity to infinity, and it's a two-part function, so we need two integral range, and it's from 0 to 1 and 1 to infinity. The first part is 1 over 2, and the second part is 1 over 2. Finally, it's 1. So it's a verified density function. Thank you. That's all. Thank you.